Welcome everyone to a new episode of Small Talk. Today again I have come here to finish a topic in 5 minutes, approx 5 minutes. And this topic is radiographic imaging. The phenomena is same as what we have already did in X-ray checkup. You might have done this already. You might have visited the hospital where one technician has taken your this X-ray of your rib cages or bones, etc. Same phenomena we use in industry. Check if there is any defect in our component. And the principle is higher the energy, higher penetration will have. So it will go to higher depth. And same phenomena is going here. In radiographic imaging, particularly use this to X-ray and gamma rays because they have lower wavelength, so high frequency, and we know energy is equal to h to mu, where mu is frequency and h is Planck constant. Planck constant is a constant. So higher the frequency, higher the energy. Higher the energy, higher it will go to a depth. So let's go further. So here let's work about the working of radiography image. As I already explained earlier, is higher the frequency, higher the energy, and higher penetration it will have. So that's the principle, and using this, we try to get the cavities in components. Here you can see this is the systematic diagram of radiographic, and you can pause the video and read about this if you want. Anyway, I will explain it a bit what is happening here. There are two electrode, cathode and anode. In anode, electron strikes. When they strike, that point is called focal point. From there, X-rays are originated, and when X-ray originated, they strike our component. If there is a flaw present there, the last film you can see here, the two intensity. If there is no cavity and when there is a cavity, in film we got a two different intensity. Using this, we exploit this phenomena, and we came to know that if there is any cavity or any defect in our component, and this is the working of radiography. Let's go further. Here I have taken one a beautiful animation and X-ray setup. Here this is the uh, what you see in books, and here it will uh, visualize it in a good way. As you can see here, this is anode, this is the cathode electrode. Two voltage are provided here. This is called cathode because here cation strike, and this anode where electron strike. When electron strike, X-rays are produced, and that X-ray we focus it on our component, and if there is a cavity, obviously the absorption rate of X-ray will be less, and where there is no cavity, of course there is more absorption, and we will get a intensity difference in the film, X-ray film. That is what is happening here, and this is the real devices to perform a radiographic image. Again, for the critical point, you can stop here and read about it. I have already explained it about this, but you can stop and read up once and take a look. Ah, here I want to show you that further the focal point is the further the distance of focal point and component is, better your image will be, less blurry it will be. But if your component is very close to focal point, the image you will get will be very blurry. This is phenomena called umbra and penumbra. uh, you might have seen the solar eclipse, or if you have not, if you haven't seen, then try a lamp and take one object and keep it between the light of rays. The shadow you will get will be like this: one a darker shadow and one some shaded portion will be there. Shaded portion will be penumbra and darker will be umbra. Simply, uh, the explanation is here. As you can see, this image more sharper than this, because this one, uh, this one is blurry because of penumbra region, and this can be reduced if we take the component further from the focal point, and using this we can minimize the blur. Again, one more, in radiographic imaging, one more rays is there, what is called gamma ray. And gamma rays actually we can obtain from a when there is a unstable atom, it tries to become stable, and like this one will be stable, and it will give one electron and two gamma rays. uh, like you can see here, in the case of cobalt, it turn into nickel, giving one electron and two gamma rays. This gamma rays has high energy, very high energy, and high frequency. As you can see here, there are alpha rays, beta rays, and gamma rays. While the alpha and beta can't penetrate much, but the gamma rays, due to very high energy, will penetrate to a long distance. As you can see here, it will penetrate paper, aluminum, as well as lead. So this is, and the working is same as same as X-ray. So there's nothing much difference between the X-ray and gamma rays radiography. Just that we are taking a another ray instead of X-ray. So we can, in if you are using gamma rays, the advantage is that the penetration is more. So the cavity we can see is much smaller, and the what we use in gamma rays are very much compact. Device is very much compact. That's the advantage of using gamma rays in radiographic image. Let's go further. These are the advantage and disadvantage of radiographic imaging. As you can see, that detect in almost all material, including stainless steel, can be seen through this. X-ray and gamma rays can be penetrate thick component and detect cracks. No surface penetration of workpiece is required. That's why it is non-destructive testing. Ports of gamma rays are very compact to use. Here I have explained it, but the limitation are there. The limitation are that give no idea how deep the defect is, and of course it is expensive. And radioactive rays are very hazardous. It is hazardous to workers or the handler who is going to handle it. And minute discontinuity are not detected, sharpness related. And here we are going to close our small talk. Okay, bye. These are the references I have selected using this to make this PPT. You can visit this websites, or you can visit this link. They are very good, like engineering fracture mechanics by Professor K. Ramesh. He is a very good professor from IIT Madras. His lectures are in NPTEL. You can visit this also. Many link. And bye bye.